Hello and good afternoon and welcome to the continuation of my previous tutorial on L2TPv3, and that is the layer 2 tunneling protocol formally defined in RFC 3931. And if you remember from our previous tutorial, we had our layer 2 setup, or I should say our layer 2 extended, and just to get the pin back on the board here, we had this address, which is a 192. Having some trouble here with my pen. 168.1.254, and this address was leveraging an L2TPv3 tunnel, right? And we had our XConnect interface here, and that tunnel was allowing us to make this interface appear as if both of these interfaces were on the same network, and this was our 192.168.1.1. And so if I move back over to router 5, and let's go ahead and do a show L2, actually we'll do a show IP EIGRP neighbors, and let's see who we see. And as you can see there, we see that 192.168.1.254. If I do a show IP route, you'll notice that it sees the 192.168.1/24 is directly connected, and we have a simple default route out the FA00 interface. So if I ping 192.168.1.254, we've got success, and the same thing here on router 7. If I ping 192.168.1.1, we've got success. So if I do a show layer 2 tunnel, a command last time on R7, you see we see nothing, because remember, the tunnel is created between routers, or I should say the XConnect interface on which we'd run this command to see the state of the tunnel based off this XConnect interface is going to be on router 6. So if I do a show L2 tunnel, right, our tunnel is up and everything looks great. Alright, so we're going to pick up right where we left off. Let me close that out real quick. We're going to pick up right where we left off. Clear my screen there, and we'll go back to the normal cursor. And you'll remember I said at the end of my last video, we've got this L2TPv3 tunnel that allows us to make R7 and R5 appear as if they're on the same subnet. However, when that traffic is being tunneled through the network, and that traffic travels this way in an L2TPv3 tunnel, and then it comes down here, right? It goes both ways. All of that traffic is not encrypted. It's unencrypted traffic. So we definitely want to encrypt this traffic to protect it, because if we're saying that on the right-hand side here, that this is going to be all the way out in San Diego, and this is going to be, or these routers would be in a building that's in New York, right? Obviously, this is our simulation of the internet, so we don't want that traffic traversing the internet, even though it is tunneled. It's not encrypted, so we want to protect that traffic. So what we're going to do now is we're going to lay down IPSec, and this tunnel is going to be encrypted with IPSec. And again, I don't need a GRE tunnel here. I can go ahead and put IPSec right on top of this, and then our L2TPv3 tunnel will be encrypted. And I'll actually show you a couple of commands that you can use in order to confirm that the traffic that's being sent across the tunnel is actually being encrypted. One of the confusing things we'll also talk about is where to apply the crypto map, and in our case here, in this topology, we want to apply it on the outside interface of routers 4 and 6. And we're going to set it up so that the local IP, or the address that's going to be using as the local IP, is going to be the loopback address again, and we're going to use that same loopback that we used previously. Alright, so let's go ahead and jump in. This should be pretty quick. We've only got 2 routers that we're going to be touching here, making configuration changes, and that's router 4 and router 6. All right, so on router 4, and if you look over here on the right-hand side, you can see I typed these commands up here so I'd have them for reference, but we're going to go ahead and walk through them. So we'll go from privilege exec into global config, and the first thing I'm going to do is I'm going to create an access list, and I'm basically going to create an access list that's simply going to allow, and I'm going to change that, it should be 115. Change it so that the protocol that's going to be matched, 115 is the protocol for L2TPv3 traffic. And you'll see this, and sometimes you see it in error messages where it'll come up and tell you that the connectivity back and forth is not allowing protocol 115. And so we're going to allow it from host 4.4.4.4, which is our loopback interface, over to the loopback interface of router 6. All right, so there's our access list. Now we're going to get into the IPSec configuration. So crypto ISACAMP, and if I do crypto, we'll do a question mark here. And you can see if I choose ISACAMP, we're configuring the ISACAMP policy. So crypto ISACAMP, and we'll do a question mark again to make sure that we see the different options. And so set policy for an ISACAMP protection suite. Whoops. So crypto ISACAMP policy, and then we can simply give it a number, right? So the priority of protection suite, so we'll say 100. All right, and then I'm going to do encryption, and you can see I've got a couple of choices here for encryption. I can do triple DES, I could do AES, or I could do just simple DES. We're going to go ahead and we'll do 3 DES. We'll do triple DES. All right, and then authentication, and let's back up actually, we'll walk through each of these. So we're going to use a pre-shared key. Right? So we'll use a pre-shared key, and that key is going to be one we create here with a crypto command. So authentication pre-share, and now the Diffie-Hellman group will be next. So when I type group with a question mark, we're going to choose Diffie-Hellman group 2. So I type group 2. Now I'm going to exit out one level, and we're going to go crypto ISACAMP and key. And the 0 means that it's going to be that what we're providing here, the CISCO, the Cisco, which is our pre-shared key, that's what I'm typing in is not encrypted. It's just plain text. All right, and then the address is going to be 4.4.4.4, and I'll type enter. All right, so we've got that down, and hold on just one second here. I think that my address statement may be backwards. Yeah, we're good there. Okay. All right, so we're good there. Whoops. Okay. So now we're going to do an IPSec. We're going to configure some IPSec parameters. We're going to configure the transform set. So the transform in the settings. So the transform set, and right here I'm just going to say R4 and dash transform. Whoops. R4 dash transform ESP triple DES, which is the encapsulation security protocol, using triple DES, and then we're going to use the encapsulation security protocol for SHA, HMAC SHA. All right, and so now that's been set, and I'll exit out one more time here. And so now we'll create the crypto map, and this will be what gets applied to the interface on router 4. So crypto map, and we can call it R4 to R6, and the local address is going to be the loopback address, and then we're going to pull that same command back up, make a modification to it. So crypto map IPSec dash ISACAMP. All right, so we get a note here. It says the crypto map will remain disabled until a peer and a valid access list have been configured. So we already configured the access list early on, so we're good there. So let's go ahead and set the peer, which is going to be 6.6.6.6, the loopback interface over on router 6. We're going to set the transform set. Whoops. And call out that it's going to be the R4-transform. Now we're going to match address, and if I do a question mark, you can see it's looking for an access list number. And so we already created an access list 100. And this is going to be one way that I demonstrate that this will show and prove that the traffic that's being matched, that L2TPv3 traffic, that it is actually being encrypted. Because if we turn the access list off, or if I remove the access list, then it's not going to match that traffic, and our connectivity between routers 5 and 7, that 192.168.0/24 or .1.0/24 subnet, is it going to cease. It'll stop. Okay. All right, so we've got that information entered in, so I'll type in end, and we're going to save our config. So now I haven't applied the crypto map yet. So if we come over here to R5, if I do an extended ping here, and we're going to ping 192.168.1.254, if I ping that address, and we're going to ping it a number of times here, we'll just put a random number in there, you can see that everything is working great. And remember, the traffic right now, the traffic that we're seeing when I'm doing the pings are going this way across the tunnel and over down to R7. And everything's working great. But it has to go through that interface right there, right? In fact, let me clear things off. Let me change colors. So this interface right here, right, is where we're going to apply that crypto map. And we'll do the same thing over here. The crypto map will get applied there. And with the traffic coming this way right now, if I apply that crypto map, it should break. And let me do show IP int brief. It should break our connectivity. And so that's Ethernet, fast Ethernet, 0/1. So if I do crypto map, and we'll do the question mark, and now it's looking for the crypto map name, and it's simply going to be R4 to R6. Now, as soon as I hit enter, I'm going to jump over here. As you can see right now, the L2 tunnel looks great. We've got that L2TPv3 connectivity running between our two sites. Now I'm going to apply the crypto map to this interface right here on R4, through which all of our tunnel traffic is transiting right now. And so let's see what happens. So I hit enter, we'll come over to R5, and sure enough, look what happens. So we've lost connectivity because I've configured a crypto map on this interface, and we've even lost our EIGRP neighbor relationship, right? As you can see, the hold time expired. From the previous video, you'll remember we configured that EIGRP adjacency to prove that we had good connectivity across that L2TPv3 tunnel. All right, so traffic is down right now. However, and another very interesting thing to note here, so you can see here, right, the protocol 115, right, that is the protocol for L2TPv3. So what we're looking at right now is we've configured router 4, and it's set up, it's ready to go. So if I were to type in show L2 tunnel, you can see that the tunnel still thinks it's established. However, we've lost connectivity. And so eventually what's going to happen here is this is going to pop up and say that there are no tunnels, or the tunnel will show in the shutdown state, and then it'll show no active tunnels, because we don't have connectivity through there due to the crypto map that was just applied right here. So what we're going to do right now is we're going to walk over to router 6. Let me roll up the screen here. So we're going to walk over to router 6, and we're going to go ahead and do the configuration on router 6 right now. And while we do that configuration, we're going to hopefully see that our tunnel is going to drop off here, because we've definitely lost connectivity. All right, so on router 6, go from user exec into privilege exec, and then into global config mode. And so the first thing we're going to do is we're going to get that access list created, and we're going to permit, right, we're going to match and then allow only L2TP traffic. So 115 host from 6.6.6.6 over to the loopback address of router 4. Okay, we'll set up our crypto ISACAMP policy 100. And then we're going to do our encryption of triple DES. And we're going to specify that we're going to do a pre-shared key, Diffie-Hellman group 2. And then we've got crypto, ISACAMP, and here's our key. There's Cisco and the address, 6.6.6.6. So we'll type in enter. And I'm going to double check that. We could have a mistake right there with the key, so this will be interesting. All right, so now we're going to do the crypto IPSec transform set. So R6 transform and encapsulation security protocol triple DES and ESP SHA HMAC. Okay, so we'll drop out one here. Crypto map is going to be R6 to R4, and the local address, and this is where we're going to signify the loopback address as the local address, not the address on the fast Ethernet interface that's on the outside going toward our service provider. All right, so we've got loopback 66 and then crypto map R6 to R4 100 IPSec ISACAMP. So our peer, and there's that warning message again. Whoops. So our peer is going to be router 4. We're going to set the transform set, which we're going to use, that we've previously defined right up here. So the transform set is going to be R6 transform and match address 100. And so that's going to match our access list, right? So we are only going to be interested in the traffic that is L2TP traffic. That's the interesting traffic. That's the traffic we want this crypto map to match and subsequently encrypt as it sends across the internet over to router 4. All right, so that looks like everything except the application of the crypto map to the interface. So let's take a drop back over here. You can see we're still getting some error messages here because it's not functioning properly. And just as we suspected, now the L2 tunnel is down. So let's take a look on R6, and do we see show L2 tunnel? Right, so it's waiting. Right, it's in a waiting state for the tunnel, but the tunnel is not established. Do we have connectivity? If we go to R5, you can see here, not much luck. Control-Shift-6. And so let's kick up another extended ping here. So we'll do ping IP 192.168.1.254. And we'll let it go for a random count. And as you can see, it's not working. We'll come over here to R7. Let's run an extended ping as well on to the other side over to 192.168.1.1. And we'll do a random number as well. And as you can see, we're not having any luck right now. So let's go ahead and let's apply that crypto map on router 6, show IP interface brief. And it's going to go on to fast Ethernet 00. So we'll go into global config mode, interface subconfiguration mode for fast Ethernet 00. And we'll apply the crypto map R6 to R4. All right. So let's jump back here over to R7 and see what happens. As you can see, it looks like the connectivity is still down between R5 and R7. Not working too well. ISACAMP is on. Let's make sure we save. Oops. Make sure we save our configs. Right. Still no connectivity. And now we're receiving another error message over here. So if I do show crypto, show crypto IPSec Security Association, we can see that we're set up. And it shows the crypto map tag. It shows the interface on which that crypto map has been applied. But right here, and this is really what we're looking for right here, packets encapsulated, packets decapsulated, right? The count is 0. So we have nothing going across this tunnel right now. We take a look at R5, still no connectivity, the tunnel is down. Take a look at R6, we'll do a show crypto IPSec Security Association. And again, we see that it's set up here, we see the name of the map, but when you take a look, nothing is being encrypted, or I'm sorry, encapsulated, nothing's being decrypted. Same thing, no packets encrypted, no packets decrypted, right? We've got nothing. And we're also still down over here. Connectivity is still down. So remember, when we took a look at the Cisco ISACamp key, when we set the key, we went ahead and we put down an address. And so you can see we've got the same address here. And so I know that this is in error. So we're going to go take a look and let's see what we did here. So we'll do a show run. And there it is right there, the crypto ISACamp key. So if I do a config T, we're going to get rid of this key. Whoops, I'm sorry. So you can see the key, Cisco address 6666, right? So if I were to run that again, crypto ISACamp key, Cisco, oops, key 0, Cisco, and then address. So it says define shared key with IP address. And so it's the peer IP address, right? So if the peer IP address is the one that's on the other router, that's the address that we're going to want to use here. So the peer IP would be 4.4.4.4. And then I can go ahead and get rid of crypto ISACamp key because that's not the peer, that's my address. So we'll go ahead and type in there. So now let's do show run. Right, and that looks much better. So the peer address is in there, but now has that established connectivity? It has not, because if we look back over here on router 4, when I do the show run, I'm looking for that peer address, and as you can see, we've got the same mistake here. So I'm going to go ahead and remove that mistake, and we're going to replace it with the peer address. 6.6.6.6. So I'm going to hit enter, and let's come over and take a look at R5. We're going to give it a couple seconds here to establish. So R7 looks like the connectivity is still down. R5, the connectivity is still down. So let's do a show L2 tunnel. Let's see what our status is. We've got no tunnel up, right? So until that tunnel comes up and that signaling protocol L2TP creates our tunnel for us, we're not going to see anything. So we're going to do an end and a write mem. Whoops. So right now our tunnel is down, and it doesn't look like our security association is up either. So we'll do a show L2 tunnel, and here we go. As you can see, the tunnel is coming up, and look at that. Sure enough, we've got connectivity from R5 and connectivity from R7. So that's fantastic. So our tunnel is back up, and our traffic inside those tunnels is now being, or I should say the traffic going across those tunnels is now being encrypted, right? So it's established there. Here it wasn't, but now it is, right? So absolutely fantastic and some exciting stuff. So we've got connectivity here between R5 and R7. Now let's take a look here. If we go to R4 now, so now if I do a show crypto IPSec Security Association, let's see if we're matching. Perfect. So whereas before these were all zeros because no traffic was going across because we had some mistakes in our config, now you can see that not only is the traffic being encrypted, right? The traffic that's being matched, which is that L2TPv3 traffic, our counters are incrementing, and the reason they're incrementing is because we've got these pings going across right now, right? So you can see pings here. So let's take a look at R6. If I do a show crypto IPSec SA, and again, absolutely outstanding. we've got packets being encapsulated, encrypted, decrypted, right? And again, the traffic that's being encrypted and decrypted is the traffic we're matching. So if I do a show access list, you can see that this access list, right, access list 100, we're permitting protocol 115, and protocol 115 is L2TPv3 or L2TP. There's different versions of it, but in any event, it's L2TP is protocol 115, and that's the traffic we're matching. So now let me show you conclusively what happens when I'm not matching anything, right? So I can remove the access list, and then it's going to deny all traffic. And so watch what happens when I do that. So as you can see here, right, we've got connectivity. Things are working great. So I'm going to come over to router 4, and I'm going to do a show run, and let's do include access so I can see that access list. So there's our access list. So if I do conf t and I drop this access list, what happens immediately? As you can see, immediately our tunnel has gone down. R5 has no connectivity, right? So R7 has no connectivity. So the connectivity, our neighbor relationship in EIGRP has also just dropped. We've got our neighbor change statement. So there is no longer an adjacency between router 7 and router 5. And it's because I removed that access list, which was matching the L2TP traffic. So what if I were to do another access list? Let's say I want to permit ICMP, right, which is ping traffic. Does that bring things back up? Because we're pinging back and forth, right? The reason it's not coming back up is because that traffic, the ping traffic, it's all going through the tunnel. It's encapsulated, right? So if you're familiar with MPLS, MPLS will put a label in front of the packet, right? So this packet, or these ping packets that are going back and forth, which are ICMP, they're actually encapsulated with an L2TP header. And so we're trying to match the ping traffic, but it's not working, right? And that's because we need to match the L2TP traffic. And so not only does this show you conclusively that that traffic is in fact being encrypted, right? It also shows you that it's being encapsulated as well, because the router is not able to see the ICMP packets floating back and forth. It's seeing the packets with that encapsulated L2TPv3 header on it. That's a mouthful there. Okay, so let's go ahead, and we just put that access list in, and now let's pull it out, right? And what I'm going to do is, we can still see, right, over here, router 7 is still down, right? Router 5, that adjacency is down. Let's drop that access list back. Oops, I should have just pasted it back in here. Hold on one second. There we go. All right. And again, we're matching 115, right? Protocol 115. So as soon as I hit enter, I'm going to jump over to R5 as quick as I can, and let's see how quickly this comes back up. R5 dropped. Let's go to R7. They both dropped. All right, our extended pings ran dead, but you can see the neighbor adjacency just came back up. So if I were to ping 192.168.1.254 from R5, we've still got some failures because the tunnel could... Oh, wait, we had a success there at the very end. So yeah, the tunnel may have been reestablishing. So if I do a show L2 tunnel again, you can see the state is established and everything's coming back up. Right? Let's come over to R6 and do a show L2 tunnel. And there we go. That tunnel is back up. So again, we've been able to extend that layer 2, right? And here we go. The tunnel looks great right here. Now, we talked about some of these commands last time, but if I do a show L2 tunnel and do a question mark, there's a tunnel option, right? Which is basically that's kind of what we're seeing right now. It's almost identical to what we're seeing with a little less information. Doesn't show us some of the, or actually is that identical? Let's check this out. So show L2 tunnel. Yeah, so we get a little more information. The show L2 tunnel command isn't showing us the virtual circuit ID, the interface. We're getting some additional information with the show L2 ton that we don't get when we do the show L2 ton tunnel. So then let's go ahead and take a look at the show L2 ton, and we'll do session, and I believe there's an all option here. So there's an all, a brief, a circuit, L2TP. So what's L2TP look like? All right, so it just shows us the circuit, but what if I do all? All right, so now we're getting a little more information here. So as you can see, it tells you the information about this tunnel. Shows you the bytes sent, right? The packets sent. Gives you the address information, and we're on router 4 here. So the remote tunnel name is R6, right? The internet address of the remote tunnel. So again, you get the remote session ID, the remote tunnel ID. Gives you a bunch of information, right? So these are additional commands that you can run to determine the state of your tunnel, right? So if I type in ping, we'll do an extended ping again, over to 192.168.1.254, and we'll do a random number of pings there. And so as you can see, right, the traffic is up, it's working great. So R6, we'll do a show L2 tunnel. We're good to go here, and we'll do a show L2 tunnel. Oops, extra L in there. Show L2 tunnel. Sorry about that. Session all. All right. And again, it just gives you more verbose output and additional information about the L2 tunnel and how much traffic's going to cross it, what's happened, so forth and so on. Okay. Trying to think if that's just about everything. So as of right now, we have a fully encrypted IPSec L2TPv3 tunnel running from our, what we're saying is going to be our San Diego office here on the right. Right, this is San Diego, and our New York office over here on the left. And we've been able to stretch that 192.168, a little period in there, .168.1.0/24, so that this router and this interface here, and this router and this interface here have a tunnel, right? This is your L2TPv3 tunnel that's running between them, and they think that they're on that same subnet, right? So if I had maybe a switch hanging off here, with some hosts, and the same thing over here. I had a switch and some hosts, right? It's a little host there and a host here. These guys would be able to communicate across this tunnel, okay? And we also established EIGRP. We have an EIGRP adjacency running between these two locations. And again, one of the best uses, or one of the most common uses that I see with customers is you want to extend that layer 2. You need to have layer 2 reachability for whatever the reason between two sites. And it doesn't have to be cross-country, right? But you want to have connectivity between two locations, and you need to have that same layer 2 connectivity, right? You need to be on the same layer 2 domain. This is a great way to do that. Another great use of L2TPv3 is when you're doing migrations, right? If you're doing a customer migration and you need to maybe extend their network into your network for some reason. And the final thing that we did is we encrypted all of the traffic that's running between R4 and R6, right? So this is an IPSec tunnel now. Okay, so we have an IPSec tunnel because this is, again, this is a dangerous, the internet is a dangerous place. So we've got an IPSec tunnel on here. We're using dynamic mode L2TPv3. And what you could also do is you could use Flex VPN. You could do L2TPv3 over Flex. You could even do L2TP v3 over DMVPN, right? And so these are two alternate technologies that you can use. Unfortunately, with the Flex, it's relatively new, and so this hardware, these are 3745s, this hardware won't allow me to do that. I'd have to check to see. I think I could probably get away with the DMVPN setup, and maybe that's something I'll do next with this as my hub, and we'll say that's a spoke and that's a spoke, right? Okay, I hope that you found this video tutorial helpful. As I said in the previous video, I had looked around and I had noticed there aren't a whole lot of videos out there on L2TPv3, and certainly not many videos that go into the level of detail that we've covered here. All right. So that is all I've got, and this is how you would create an L2TPv3 topology and how you would then go ahead and protect that L2TPv3 tunnel by encrypting that traffic with IPSec. Again, I hope that you find this video tutorial helpful. Who knows, maybe you'll end up using something like this someday. I am going to be doing an additional video. Right now we're doing the Ethernet encapsulation, right, where we're doing the X-Connect on a single interface. I'm actually going to go ahead and do up a video tutorial here in the future where the encapsulation method is going to be 802.1q, so VLANs, right? And I'm going to show you how, if you had a router, it's sort of like a router on a stick configuration, where you can go ahead and extend those VLANs across this same tunnel, right? As opposed to doing it with the Ethernet encapsulation type. Okay. Best of luck, and again, hopefully this video helps you out. Have a great evening.